So, hello students, we shall continue with the second part. That is, now we'll be seeing is the second order effects of gravity loading. Now in this, we shall see what is a P delta effect and how the analysis is to be done, or the calculations for the P delta effect. So to that, first we shall see what is the P delta effect here. Now P delta effects are also known as the second order effects. So this second order effects of gravity loading is nothing but the P delta. Now this delta, it is this capital delta here. Okay, this big delta which is there, that is the P delta effect which we consider. And this delta is nothing but it is the displacement. Okay, so this P is the force acting or the gravity load which is there. Here will be the lateral wind load will be acting on the structure, the gravity loads will be acting, and this P which is there is nothing but the force. Okay, it is a force of gravity which is multiplied by the distance or the displacement, horizontal displacement, that is delta. So we call it as P delta. So now P delta is also known as the second order effects. Okay, and here the magnitude, okay, that is the magnitude of this P delta, it depends upon the amount of initial displacement. Okay, so whatever initial displacement is taking place, so that is, we say, when the first order takes place, first order effects are there, that is when the, suppose here on the structure you have the horizontal loading as well as the gravity loading. So when the gravity loading is acting, there will be certain amount of displacement there with this horizontal loading. So now when the certain amount of displacement is there, later we, in certain assumptions, when we are doing the assumptions, we consider that the smaller values of the displacements, they are neglected. But later what happens, when these displacement they get cumulated, they cause a larger effect. So that effect which is there, it will cause the secondary order or the second order effects. So later, due to first order, when it is having certain amount of displacement, and this further the effects of this gravity loading and the horizontal loading, they increase this displacement. So that amount of, again, further displacement which is occurring, that is the, we call as the second order effect or the P delta effect. So here it is again shown. The P delta effect, it is a destabilizing moment. So it is nothing but P into delta. Okay, so P delta is a moment here. The destabilizing moment, which is equal to the force of gravity P multiplied by the horizontal displacement of this structure undergoing the lateral loads. Okay, so this is the P into capital delta is the effect which is occurring. Now here one more you can see is P into small delta. Okay, now this P into small delta is nothing but the deflected shape here, okay, from the joint nodes. So the P is the force acting and gravity loads, and this delta, small delta, is a deflected shape. Okay, so that is P delta effect here. But what we study in here is the P capital delta effect. Here we can see the maximum deflection from the axis of the walls of the column. So now here the first order analysis, when we consider of the building which is having the gravity load and the horizontal load applied, then while getting the results of this deflection and the forces, okay, they are considered separately, the results, and then they are superimposed. Okay, that is mentioned here. The first order analysis of the building for simultaneously applied gravity, okay, the gravity loads and the horizontal loading in deflection and the forces, they are direct superposition of the results of the two types of loading considered separately. That is, both gravity and the horizontal loading values, they are considered, they are analyzed or found out differently, and then their superposition of the results is done. Then if there is any interaction between these two effects, they are accounted for the analysis. Now again, further we define it as when the horizontal loading which is acting on the building, it causes it to drift, that is when it makes it to sway. Okay, the resulting eccentricity, okay, because as the it gets shifted, the eccentricity will be produced there. Then the resulting eccentricity of gravity loading, that is nothing but this, the eccentricity which is produced of gravity loading from the axis of the walls and the columns, they produce the additional external movements to which the structure responds by drifting further. Means due to this again further drifting, that is the movement produced, it will move further. There will be again more displacement taking place. So the additional drift which is produced produces the additional internal movement. Again, as the external this drift is there, to keep in equilibrium, it produces the additional internal movement that is given here to equilibrate the gravity load moment. So the effect of this gravity loading P, which is acting on the horizontal displacement, is known as P delta effect. So these are just the definitions and the explanation of P delta effect here. Then the second order P delta additional deflections and moments, they'll be producing the small amount of additional deflection and movement. So that is given here, and these values which are there, the additional deflection moments, they are about less than 5% of the first order values. So for first order values, whatever you get the deflection moments, they are at a large value. But when we consider second, that is a P delta effect or deflection and moments, they are very small. They are about less than 5%. Okay. Then in extreme cases, when we consider combined, that is, it is having the gravity loading, the additional forces from the P delta, due to this P delta effect, what it happens is the strength it exceeds of the strength of the member exceeds, and it causes the collapse. Okay, that it causes instability and it causes a collapse. Then that is in some cases, it is not always, but it is said that this P delta external movement will exceed the internal movement, causing the collapse of the building. Now this is about the twisting. When this is about the, that is movement, that is the displacement is taking place. Suppose if there is a twist occurring in the building, that is the torsional mode is to be considered. So when torsional mode occurs, the building will twist. Okay, it will twist with its walls and frames will displace from the center of rotations in each floor, and that time we need to take the torque. Okay, torque constant to be taken. So the gravity loading gets misaligned. So gravity loading which is acting, it gets misaligned and causing additional torque here. So the building will twist more. Okay, when the internal resisting torque and the external resisting torque are not in equilibrium. So internal resisting and external resisting, if they are equilibrium, they are balanced, then the building will not twist. So here when the torsion is occurring, we need to take the torque constant there. So internal resisting torque and the external P delta torque, okay, that is external and the internal torque, they depend on the planned location of the gravity loading which is to be included. So when you are doing the analysis, we need to consider the torque here. So the more, if the vertical bends, that is the columns and all, if they are widely dispersed from the center, then these will be able to resist the torsion and the P delta torsional effect. That is, the vertical bends are present, widely present, then it resists. Now the different methods for the analysis, the P delta analysis is, say, first one is approximate method, accurate method, then there is the iterative methods, we say direct method, okay, and two methods wherein the structure is modeled. So we shall see all these methods of analysis. So first is the approximate method, wherein a constant amplification factor is applied to all the results of the first order analysis. Okay, we shall see this. So here what we do is an approximate method, or amplification factor is considered, which will be applied to the results of first order analysis. So here they do the first order analysis and then consider the amplification factor, and that is called as the approximate method. Second is the accurate method. In accurate method, what we do is we do the iterations. Okay, we follow the iteration method here. So it involves the iteration of the first order analysis. So here also, first you should get the results of first order analysis. Iteration is done with it with primary lateral forces, which is augmented by increments whose effects are equivalent to gravity load. So the lateral forces get augmented, increased with the effects. So increments are added to it, so that iteration process is continued here. This is in case of accurate method. Then in the same way, it is second iterative method, wherein the gravity loads are applied to the laterally deflecting structure. When the horizontal force is acting, the structure is deflected. For that, the further gravity loads are added and then are applied, and then the iterative process is continued. Next is direct method, and this is for the rigid frame structures, wherein here the iterations are avoided. The iterations are not considered by making a direct second order adjustments. Here we do certain second order adjustments of displacements and the moments. This is the direct method. And last is the two methods in which the structure is modeled, so that the stiffness matrix analysis. Here we consider the stiffness matrix analysis. Stiffness matrix is considered, which will be having both the first order and the second order effects. So we shall see in detail each analysis procedure here. So first is the amplification factor P delta analysis. Now here we consider a vertical cantilever. Okay, so suppose this is a cantilever here, and wherein the lateral forces are applied, the wind load is applied, and that is uniformly distributed. Okay, this is uniformly distributed horizontal load, and the addition of concentrated vertical load P. So here this arrow which is shown, it is the vertical load P which is at the free end. So cantilever is fixed at one end and it is free at other end, and this is a horizontal loads acting uniformly distributed, and at the free end you will be having a concentrated vertical load P, and the cantilever increases, free end of the cantilever, it increases the horizontal displacement. Okay, so when this horizontal load is there, okay, it is acting for the cantilever. Further, when you add again a concentrated load P at the free end, it further gets displaced again. Okay, and that is represented by the amplification factor F, right? So here it is nothing but the gravity load P which is there, the vertical load P is acting at the free end, wherein it causes the certain amount of increase in the horizontal displacement, and that increase is the amplification factor F. So it is given by the formula F is equal to 1 the whole divided by 1 minus P upon PCR. So PCR is the concentrated vertical load which is acted at the top. Okay, at the top which is acting here. So in which PCR is the concentrated vertical load at the top which causes the buckling of the cantilever. So due to this, it is acting downwards, it causes the buckling effect. So here we can see in this figure, it is this vertical P load which is there, it is made to distributed throughout in the form of axial load throughout the cantilever there. Then when this is taking place, the final displacement, that is delta star, this is found out in terms of initial displacement delta. So it is given by the formula F into delta. So F is the amplification factor into the initial displacement. So total displacement is given by the amplification factor into initial displacement. So the amplification factor F is given by this formula. So we substitute that, we get the 1 upon 1 minus P upon PCR capital delta. Then further, this amplification factor, it will be constant throughout the height, and it increases in deflection in proportional to initial displacement. So this F will be constant throughout the height. Okay, and as the initial displacement increases, then the final displacement also, deflection also goes on increasing at each level. So when the amplification factor method is used for the structures with the gravity loading, wherein it is distributed throughout the height, the total drift which is taking place, it is found out by, okay, total drift we find out. So delta star is equal to 1 upon 1 minus PO. Okay, here we consider the PO. This is for the throughout the height here. So the total gravity loading and POCR is overall buckling loading into delta. So the total displacement of the drift is delta star is equal to 1 upon 1 minus PO upon POCR delta, where it considers throughout the height. So the total gravity as well as the total buckling load is considered here. Now this is for the load. So we know due to this acting load, there will be the movements will be taking place. So we need to find out even the movements here. So the initial movement we represented by M, okay, from the first order analysis. Okay, so this is for the first order before applying the P there. So whatever results we get, movements we get is M. Now when we add that load extra, certain again more amount of movement is increased. So that movement which is increased, the second order movements, is called as the final movement M star. So M star will be equal to 1 upon 1 minus P naught POCR into M. So same way here it is M, that is the movements. So final moments and the total drift we produce. So the analysis of the total drift and the moments at limit state it will require is the first order analysis of the structure for the factored horizontal loading. We require the results of this first order analysis. Then evaluation of the amplification factor, okay, that is F, using gravity, factored gravity loading and the critical buckling. So this is in the limit state. So factored gravity loading and the critical buckling load either from approximate method or the rigorous analytical method. So these values which are there, we find out from the previous equations which we have studied. From that we get these values, that is we get the from the approximate method and the rigorous, that is from the analytical method. From that we find out these values here. Then the increasing drift and the moments which is there, so this PO PCR we find out from the, that is we have studied the shear and the movements. So from that we find out those values here. Then the increasing drift and the movements in the structure from the horizontal loading in the first order analysis by amplification factor, that is we multiply by the amplification factor, we find out the what is the drift and the movements, that is this delta star and m star. So adding the results, when you add the results from the horizontal loading to the force in structure determined for the gravity loading. So this is the procedure for the approximate method. Approximate method, the main is the amplification factor is considered, and then the increased values are found out, that is the total drift delta star m star by using this formulas. The next is the iterative p delta analysis. Then for this, for iterative p delta analysis, for heavy gravity loading, that is a large amount, the gravity load is more and the flexible structure, amplification factor does not hold good. So that is when the heavy loading is there and the structure is very flexible, you don't go for the first, that is approximate amplification factor method. So now here in the iterative p delta analysis, the second order method, an initial first order analysis of the structure is made, okay, with the external horizontal loading. So the horizontal loading acting on the structure, from that the first order analysis is considered. Then the results which are obtained, horizontal deflections, they are used with gravity loading. Then we apply the p value, the gravity loading, to find at each floor what is the increment of the horizontal load. So now here what we do is, first we find out the first order analysis, okay, wherein the horizontal loading is acting. Later we apply the gravity load, that is a p at the free end say, and then we find out in each floor what is the increase in the horizontal load, okay. So whatever horizontal deflections are used with the gravity loading, they used to find at each floor what is the increment of horizontal load. Then this increment is added to the initial horizontal load. Suppose initial horizontal load is h, and due to which there is a certain amount of deflection. So now the deflection, wherein after getting the deflection we find out what is the increase in horizontal load, where it is a small delta h. So that small delta h is added to the initial horizontal load, that is h plus delta h, and again it is applied to the structure and the analysis is repeated, okay. So here what is done is iterative method, that is we go on adding the increments of horizontal load. Then here it is given, the resulting increased horizontal deflections are used with gravity loading to find another set of increased horizontal loads, and again whatever increment is there, it is added to the initial horizontal load for reanalysis. So here this procedure goes on repeating, that is you apply the horizontal load, what is the deflection you find, again what is the increase in the horizontal, you find that delta h, and that delta h is again added to the horizontal load. So this procedure is repeated. So till when it is repeated is, the iterations are continued until the increase in deflection becomes negligible, okay. So when this deflection becomes almost negligible, till then you have to go on repeating the process here. So this method is applicable to all types of frames, walls and the other forms of structures. So here is the, wherein you can see this delta q I h I is equal to pi into delta I, where I is the floor level there, okay, story level. Then here, as I've explained you how it is, So first I'll show you this. Suppose this is a structure wherein it is getting deflected, okay, initially. So Q1 and Q1 is the shear forces. This is the delta 1, and due to that the moment is produced, that is Q1 into delta 1 is a moment here. So column is deflected by shear here. Now second one is the axial load is applied, right? We apply the gravity loading. So Q1 P1 and is a delta 1. So this Q1 and this is the first P1 here. So here additional will be P1 delta 1, right? So it was Q1 that is delta 1 as well as P1 delta 1. So this is the addition moment here. Then this is the augmented one. So Q1 plus delta Q will be the increment here, right? It is given here P1 Q1 plus delta Q1. So this values which are the Q delta Q1 H1 is equal to P1 delta 1. Now same way, that is the shear which is there. So delta Q1 when we delta Qi, I is the I floor level, will be equal to Pi delta I small delta I that is there. Here it is represented upon Hi. This is the value giving the equivalent increment of the shear. So what is the increment of the shear horizontal load, which is the increase in that load? It is delta Qi. So now when we consider the resultant effect of the shear increments, that is at each floor it is shown. So level, say here 1 minus 2, 1, 1, 1 minus 1, this is a level 1, this is level, sorry, I plus 1. Level I plus 1, level I minus 1 and level I minus 2. So height is again h of I minus 1, hi and hi plus 1. This is the height of the structures given here. Now these are the, that is the deflections given here, displacements. So here it is delta h I minus 2, delta h I minus 1, delta hi and delta hi plus 1. So this is given is the that is the displacement given at each level. So at I level we find out it is delta I is equal to Pi, and so here it is mentioned as 1, or you can take it as I level there. So it is Pi upon Hi into delta I of delta I minus 1. So it is delta I present here, okay, of I delta of I minus 1 or 1 minus I. So it is given this value, that is the deflection of delta Q1. Now here this is just an example showing for that. Then further delta Qi which is there here. So Pi which is their value into delta I, it is found out from this value. So it is given as capital delta I minus delta of I minus 1 upon H1. So the resultant additional increment of the horizontal load to be applied at each floor will be equal to delta H. Okay, delta H, the horizontal load, is equal to delta Qi minus delta of Qi plus 1. Delta of Qi plus 1 there. So wherein the values, so here what we have delta H, okay, this delta H which is there, I is equal to, we have found out from first order analysis which we have studied before. So here it will be minus Pi delta of I minus 1 Hi plus Pi Hi plus Pi of I plus 1 H of I plus 1 and minus Pi plus 1 H of I plus 1 upon H of I plus 1. So this value which is there delta H, the increment is added to the original horizontal load. So whatever original horizontal load is at, for that the increment will be added. This increment, that is delta H, will be added, and then the reanalysis will be continued there. So here also this procedure, as it is said, it is continued till the displacements become 0. So a set of horizontal increment causes at any level of the structure the same additional movement as it would be for the set of the gravity loadings if it is acting on the structure. Here it is Q1 H1 plus P1 delta 1 and Q1 H1 plus P1 delta 1. So this delta which is there, capital delta, it is this displacement here, okay. So this displacement delta of I plus 1, capital delta delta. Small delta is the shapes, that is the increment value. It is the increment value in the shear forces. The next we have is the iterative gravity load P delta analysis. Now in this, what is done is, as in the previous method, the repetitive increment is going on added. So because we go on adding the incremented value and then again do the that is the analysis. So it becomes a tedious process. So for that, in this method it is avoided. So in this iterative gravity load P delta analysis, we avoid that iterative process and we make it a simpler method for the iterative gravity load analysis. So after the first order horizontal load analysis, whatever we get, using the frame analysis program, okay, the gravity loads are applied to the unloaded structure reflected by first order values, say of drift delta I. You get the increment in the drift, that is delta I1. So this is the increment taking place. Okay, so due to first order analysis using the horizontal load, during using the program analysis, you get the first order values, that is drift delta I. So the increment is small delta I, so as shown in the figure here. So this is the delta I here, and this is the increment delta I which is taking place here. So now this delta I1 which is there, it is the gravity loads are applied to the structure deflected by increment delta I1 to obtain another increment is delta I2. So when you apply this delta I1 further, there will be a further increment, there will be further increase in the drift. That increment is delta I2 here. So delta I2 value is find out. So this procedure is again repeated, okay, until the drift increment delta is very small. So that is, first apply horizontal load, then to the undeflected or the structure, unloaded structure, and the first order values of delta I. Then you get the increment of drift delta I1. Then this delta I1 is again added to the structure, gravity loaded structure, and we find out delta I2. Again this delta I2 is added. Again we find out what is the increment delta I3. So this process gets repeated till the delta value which is there, additional drift, it becomes negligible. And the final drift in the story I, we find out, which includes the P delta effect, which is the sum of first order drift and all the increments. So it is given by delta star, that is the total drift, final drift, is delta I. Delta I is the sum of the first order drift, okay, sum of the first order drift plus these increments, delta I1 plus delta I2 plus delta I3. So the iterative process is required because when vertical loads they are applied, okay, that is those gravity load, so in actual they are not applied in the final deflected shape. So the final movement at the story, if you want to find the final movement, that is mi star, it is same as the first order movement mi plus these increments. So same way, that is we apply the movement and then we find out what is the increment in that movement. Further again when we add the incremented movement and find out, there will be again certain increment, that is will be mi2. So like that we find out these increments in the movements and we add it to the first order moment mi value. So I is the story level at that. So this method can be simplified by adding a full height axial rigid fixtures column. So for this, to simplify it, we add here, so it is shown here. So we add one fixtures column, okay, gravity loading column, and to that it is for the full height throughout the height of the structure, where the flexural stiffness will be taken as 0, and it is connected to the structure either by the internal node horizontal constraints, these internal node horizontal constraints, or the rigid links. Okay, it will be connected either by the internal intern node horizontal constraints or by the axial rigid links. We add it to the fixtures column we make, and then we use this procedure. So the total gravity loading will be applied only to the levels of the deflected fixtures columns. Okay, wherever the deflection fixtures column is there, for that part the gravity loading will be applied at that floor level, and same iterative manner will be continued and not to the entire structure. So results obtained, they will be same as the previous iterative method, and this process will take a lesser time. So this procedure or this method of analysis will take 1/3 of the time as compared to the iterative method there. Now next is direct P delta analysis. So this we shall see in the next video. Thank you.